Now, we're going to take up one more problem, the problem number 50. It reads as, a rigid bar weighing 1 kilonewton supports a vertical load of 4 kilonewton at its midpoint. It is attached to the fixed ceiling using a steel wire of diameter 3 mm and two aluminum wire, each of 5 mm, as shown in the figure. So here we have the diameter of using a steel wire of diameter. So this is diameter 3 steel wire and aluminum wire each of 5 mm. So this is aluminum 2 wire which is fixed to the ceiling, and 1 kilonewton is the rigid bar, and over which 4 kilonewton is acting at the midpoint. Determine the stress in steel and aluminum wire. Steel and aluminum wire, what is the stresses and load carried by each wire? So what is P aluminum, PS, and okay, and also the distance moved or come down by the rigid bar. So because due to the load applied. So we have the Young's modulus for steel, which is 200 GPa, and Young's modulus for aluminum is 70 GPa. Now, so here the diameter of the steel bar is the data, whatever it has been given here. The diameter of the steel bar is 3 mm and the aluminum bar is 5 mm, and length of the steel bar is 800 mm and the aluminum bar is 500, and the Young's modulus of steel is 200 into 10 to the power of 3 Newton per mm square, and the Young's modulus of aluminum, which is 70 GPa, which is equal to 70 into 10 to the power of 3 Newton per mm square, and P is equal to 5 kilonewton, which is 5000. Stress in the steel and aluminum wires we need to find out. First, what is that? Total load will be equal to load carried by steel bar and plus load carried by each of outer aluminum wire. What is the load? Let load will be equal to capital P. That will be equal to PS plus PB, PAL plus PAL. Let PS be the load carried by the steel wire and PA is the load carried by the aluminum wire. Therefore, P will be equal to total load, which is equal to 1 plus 4, which is equal to 5. 1 is the rigid plate load plus 4 kilonewton is applied at the midpoint. Therefore, 1 plus 4 will be equal to 5 kilonewton, which is 5 into 10 to the power of 3 Newton or 5000 Newton. So therefore, PS plus PA will be equal to P. So symmetry, the outer aluminum wires carry equal loads. So PS plus 2PA will be equal to 5000 Newton. So now what is PS? PS is nothing but sigma S into AS plus 2 into sigma A into AA will be equal to 5000. So now what is that? Sigma S into what is AS? Pi by 4 into dA square plus 2 into sigma A into pi by 4 into dA square will be equal to 5000. So sigma S into pi by 4, when you are taking this to the right hand side by cross multiplication, sigma S into 3 square plus 2 sigma A into 5 square will be equal to 5000 into 4 divided by pi. So on simplification, you will going to get it as 9 sigma S plus 50 sigma A will be equal to 6366.2. So also we know that delta LS will be equal to delta LA, which is equal to, assuming that the bar remains horizontal even after stretching, because the load is applied from the top towards the bottom side. So therefore it will going to have the tensile load. Due to that, you will going to have the stretching. So what is delta S? Delta LS is nothing but PS into LS by AS into ES will be equal to PA into LA by AA into EA. So what is PS by AS? This is nothing but sigma S into LS by ES will be equal to sigma A into LA by EA. You know the value of the length of the steel bar and the Young's modulus is equal to, you know the length of the aluminum bar and as well as the Young's modulus. So substitute that sigma S into 800 divided by 200 into 10 to the power of 3 will be equal to sigma A into 500 divided by 70 into 10 to the power of 3. So on simplification, sigma A will be equal to 0.56 into sigma S. Now you substitute this value in this particular equation, that is 9 sigma S plus 50 sigma A will be equal to 6366.2. So when you substitute that, 9 into sigma S plus 50 into sigma A is 0.56 into sigma S will be equal to 6,366.2. So on simplification, you will going to get the stress in the steel wire, which is sigma S, will be equal to 172.06 Newton per mm square. So once you get that, stress in the steel wire will be equal to aluminum wire will be equal to 0.56 into sigma S, which is equal to 0.56 into, substitute the value of sigma S as 172.06. On simplification, you will going to get it as 96.354 Newton per mm square. Now, what is the load carried by each wire? So first, load carried by steel wire will be equal to PS, which is sigma S into AS. You substitute the value of sigma S as 172.06 into pi by 4 into 3 square. On simplification, you will going to get it as 1216.2 Newton. Similarly, load carried by aluminum wire, PA, will be equal to sigma A into AA. What is sigma A? Which is 96.354 into pi by 4 into 5 square. On simplification, you will going to get it as 1891.9 Newton. Similarly, distance moved by the rigid bar. So that is delta LS, elongation of the wire, delta L will be equal to either the elongation of the steel wire or the elongation of the aluminum wire, as both the wires are fixed to the same rigid bar. So that is PS into LS by AS into ES will be equal to sigma S into LS by ES. So you know the value of stress and length of the steel bar and Young's modulus. So you substitute those values. Sigma S is 172.06 into length of the steel bar is steel wire is 800 divided by 200 into 10 to the power of 3. On simplification, you will going to get the distance moved by the rigid bar will be equal to 0.688 mm. So this is how you will be able to solve this problem. And we have, let us take one more problem. A 51st problem. A weight of 300 kilonewton is supported by short concrete of 250 mm square section. The column is reinforced with 4 steel bars of cross-sectional area 5500 mm square. Find the stresses in steel and the concrete if ES will be equal to 15 times EC, that is modular ratio is 50. If the stress in the concrete must not exceed 4.5 meganewton per meter square, what area of steel is required in order that the column may support of a load of 500 kilonewton? So here you have a 250 mm square on which you will going to have 4 bar of cross-section area 5500, that is 5500 mm square. So here in this stress in steel and concrete, we need to find out what is the total cross-sectional area of the steel rod, which is AS will be equal to 5500 mm square. Therefore, total cross-sectional area of concrete will be equal to AC, which is 250 into 250 because it is a square cross-section, minus the cross-sectional area of the cross-sectional area of the steel rod, which is 5500, which will be equal to 57,000 mm square. Since the column is reinforced naturally LS will be equal to LC. That means the length of the steel is equal to length of the concrete. Therefore, load carried by steel rod plus load carried by the concrete column will be equal to total load supported by the column. So what is that? PS plus PC will be equal to capital P. So what is that? PS is nothing but sigma S into AS plus sigma C into AC will be equal to what is total load, which is 300 into 10 to the power of 3 because 300 kilonewton is the load applied. So also we know that delta LS will be equal to delta LC, that is PS into LS by AS into ES will be equal to delta LC is PC into LC by AC into EC. So what is PS by AS, which is sigma S into LS by ES will be equal to PC by AC is nothing but sigma C into LC by EC. So we know that length of the steel bar is equal to length of the concrete. So sigma S by ES is equal to sigma C by EC. So sigma S by modular ratio ES will be equal to 15 times EC. That is therefore sigma S will be equal to 15 times sigma C. So now you substitute this 15 times sigma c in this equation, that is sigma s as 15 times sigma c into area of concrete is area of steel is 5,500 plus sigma c into 57,000 is equal to 300 into 10 to the power of 3. So on simplification, you will going to get the sigma c as 21.5 Newton per mm square. Therefore, the stress induced in this concrete is 21.5 Newton per mm square. Similarly, the stress induced in the steel rod is sigma s will be equal to 15 times sigma c, which is 15 into 21.5, which will be equal to 32.25 Newton per mm square. So, if sigma c equals 4.5 meganewton per meter square, so that will be equal to 4.5 Newton per mm square. If F is equal to 500 kilonewton, that is 5 into 10 to the power of 5 Newton, then what will be the area of steel? So if sigma c is 4.5 Newton per mm square, what is sigma s? Sigma s will be equal to 14 into sigma c is given to be 4.5. So on simplification, you will go and get it as 67.5 Newton per mm square. So now you substitute that sigma s is 67.5 into as will be e plus 4.5 into 250 square minus as, because area which I want to know, which will be equal to 5 into 10 to the power of 5. This 250 is the area of the concrete which we have, 250 square minus area of steel will going to give you that value, which is 5 into 10 to the power of 5. So on simplification, you will going to get it as 67.5 into as plus 281,250 minus 4.5 into as will be equal to 5 into 10 to the power of 5. Therefore, on simplification, as will be equal to 3,472.22 mm square. So this is how you will be able to calculate these values. Then, if you find this video is useful, please subscribe to my channel. Thank you.